Here I asked you what is the probability that A is cancelled but B is not. So it's simple. Um, I'm going to use this notation. I will denote cancellation as 1 and non-cancellation as 0 as usual. And then the event we are interested in, the event we are calculating the probability for can be written this way. A equals 1, so A is cancelled. Uh, B equals 0. Ah, it's typo. B is not cancelled. Excuse me, it's my typo. So we are looking for A equals 1, B equals 0, right? And we know that the probability that A is cancelled is 10%. And probability of A not cancelled is 90% automatically. So it is straightforward. Obviously, probability of B not cancelled is also 90% because they are the same binary distribution. And then what we are looking for is we are looking for the probability that A is cancelled and intersection means and A is cancelled and B is not. Then they are connected by intersection, and using the statistical independence, we can use the multiplication rule that so this probability equals probability of the first event times the probability of the second event. And we know probability of each event. We know that probability that A is cancelled is 10%. And probability B is not cancelled is 90%. So as a result, the probability we are looking for equals this, which is 9%. So the answer is 9%. I think most of you have thought the answer would be 10% because one is cancelled and I'm only giving you the probability of cancellation. So most of you may have thought the answer is 10%, but then those guys usually miss this point. You have to consider this event. There's something happened other than cancel, even if it is not canceled, but that is another occurring. Something has occurred, which means non-cancellation. So you have to take that event also into account. So this part is usually overlooked. So that's why many students and many people are confused with binomial distribution. That's the first point. And now, then, I will ask you a similar question, but it's very tricky, very slightly different. So think about this. Now, I will define random variable y as the number of cancellations. So it's number of cancellations. And still we have two reservations. Simple. Everything else is same. 10% cancellation probability, independence. And then I'm going to ask you this way. What is the probability that y equals to 1? Which means what is the probability that the number of cancellations is 1? So only one out of two reservations is cancelled. What is that probability? Try answer this question. And I said there is a trick. It's actually the answer is not the same. Then think about what is different. Why it cannot be 9%. Think about that. Okay, I'll show you the answer. The answer is it can be easily answered if you think about the 2 by 2 cases. Because A, there are only two reservations, and for each, there are two possible outcomes. So at most, there are four possible outcomes. Four possible combinations of outcomes. So it is easy to list all possible cases. There are four cases can be written in this table. So A cancelled, B cancelled. A not, B canceled, A canceled, B not, both not. So it's all of the possible outcomes. Now you have to think about what we are looking for. The 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 event we are interested in, number of cancellations equals to 1, includes these two outcomes. This event includes two outcomes here and here. Because one is canceled, only one is canceled, that means it can be A or it can be B. There are two different outcomes. Then this event's probability is probability for this plus probability for this. It is exactly what we did in chapter 1. In 2x2 table, 2x2 probability table, just check what's the outcome included in the event and sum those probabilities. Then you get the probability of the interested outcome. And here, we are going to add this probability and this probability, this and this. And you know how to calculate this probability. Probability of intersection can be written as multiplication by the statistical independence. Also, another intersection, another multiplication. So, and in the end, these two are the same probabilities, right? So, same probability, same probability. So, each of them has 9%, and there are two of them. So as a result, the answer is 18%, right? It's tricky. The answer is 18%, and it's clear if you think about 2x2 outcome case. Then what is the difference? The difference here is, excuse me, I'm sure the difference is that in the earlier question, I'm asking you only about this specific outcome. A is cancelled, but B is not. That's my previous question, so the answer was 9%. But now, I did not specify who cancelled. I just told you one is cancelled, but I don't know who cancelled. So you have to think about all different possible scenarios, right? So if one is cancelled and the other is not, there can be two different combinations. A could be the one who cancelled, or B could be the one who cancelled. Therefore, when I write it this way, when I only specify the total number, not exactly who did it, then it complicates the problem a lot because you have to count how many possible combinations there are, right? So if you get it, I'm going to continue to 3 reservations case. It's now it becomes slightly more difficult. Now we have 3 reservations, A, B, and C. Still, we define Y as the number of cancellations among the 3 reservations. So can be at most 3 and minimum 0, right? 0, 1, or 2, or 3. And same, probability cancellation is 10%, and they are independent with each other. In this case, what is the probability that only one of these 3 reservations is cancelled? You may use the same rationale I showed you earlier and apply that here. Now, it could be a little bit more difficult, but you can try. You can try to apply the same principles here and try to answer this. I am going to show you the answer and the solution in the next video. See you later.